Welcome to Simply Scripting. I'm your host, Dorex Delicioso. In our third episode, we'll finally get around to the promised script to make objects talk and listen to each other. We'll start with some more examples of user-defined functions, how we can use them to our advantage, and how we can use global variables with them. Starting with this episode, I won't be using the standard script edit window. I'll be using a third-party one called VS Code. It looks a little different, but it works the same way, and it has the benefit of color-coding our scripts. It will hopefully also allow you, the viewer, to more easily follow along as we write the scripts. So, we have our desk all loaded up and we're ready to go. We will of course be making our reliable default cube, but this time, I'm going to add some special textures I've made to it. It's still the same old cube, just with a fresh coat of makeup. I'm also going to be doing an update to our default script. Oh no. Not to worry. I'm just going to be adding in some comments so we know where things go, and a couple of lines we can reuse to make our life easier as we go on. So, sit back and enjoy. This is going to be a fun one. Here's our new default cube. Cute, right? I think so. I've created two cubes because we'll be needing one to act as the talker, or sender, and another one to act as the listener. I've changed the color on the listener, just so we'll always know which one is which. I've also renamed them, and their scripts, sender and listener. I thought that made sense. We'll open the script on the sender, and get it into our brand new script editor. First, we open it the same way we would any script. Now, we click the Edit button at the bottom of our script window. Once we've pressed the Edit button, we can resize the default editor, as I have here. We still want to see it in case we have any errors, the default script editor will tell us. But, we don't need the build window, so we can close that one. Here's our new script editor window. Isn't it pretty? So many things are different than the Second Life script editor. Not really. Actually, other than colors, they're exactly the same. As we scroll through it, we see the default state. The global work area above it. We see some event handlers. Some we may recognize like touch start, others like listen, or change, you may not recognize. What we do have is comments. Lots and lots of comments. In the script editor, any line starting with 2 forward slashes is considered to be a comment. The script won't even look at those lines, in fact, it throws them out. A bit of history. There are two types of programmers. It doesn't matter what programming language they use, there is always two types. The first one uses comments to document their code. To give a written version of what the code is supposed to be doing. The other programmers believe code should be self-documenting, and you should be able to determine what it does, just by reading it. Those second types. They're wrong. WRONG. So you can tell where I stand on this issue. It has been proven that 20% time is spent maintaining it. You don't have to comment your code, but when you come back after 6 months to fix or add something, well, you're going to wish you had of. You're going to spend a lot of wasted time trying to read that self-documenting code. It's far easier to come across a comment that says, read the note card data, than it is to read all the lines that make that process happen. Okay. Off my soapbox for now. This is my standard template for writing any script. I have this file saved in my inventory, and take a copy each time I start to write a new script. Because a lot of scripts I write are for non-scriptwriters, or very beginner scriptwriters, it helps them if I use the basic functions. While there are many fancier ways to save some memory, or make the script's execution a bit faster, I have to trade that off for scripts that are easier to understand. At the top of the script, there is a place to add what this script is called, and a brief description of what it does. After that, a simple constant called do_debug. This is used, way too much, to try and figure out why something's not working the way it should. It's just part of a homegrown user-defined function that I find useful. After that, there are comment headings for where I put variables, constants, my user-defined functions and more. So, there really is nothing special here. Just some things I've added to help with my personal work process. Your process may differ, in which case I would encourage you to make a template for yourself that you can reuse. There is no benefit to recreating the same thing over and over. The first thing we're going to do is create a user-defined function that will send a message for use. We'll call the function sendMessage, because we like to use descriptive names for functions. The sendMessage function will take in one parameter, a string variable we'll call message. So far, it all makes sense to me. Our sendMessage function is going to be responsible for sending out a message. That's all it's going to do. We try to keep our functions responsible for only one thing at a time. In the body of our function, we'll add the ll_say function we're used to. We'll instruct ll_say to repeat whatever it sees in the variable message. For now, we're going to have ll_say send messages to the public channel, just until we know this part is working correctly. We build up functions one piece at a time, always making sure they work before adding more code. We can test our sendMessage function by calling it from the touch start event handler. That's all we have to do, add the function name we want to execute, and pass it any parameters it's expecting. We don't have to know what the code in the sendMessage function does. We really don't care. All we know is that executing that function will send a message. It's the black box approach to programming. I don't know how it does it. I just know that it does. Not really too different than not knowing how your smartphone does everything it does. You know it does, you know it works, and you don't care how. We'll save this script and test it by touching our sender cube. So, we see that our script does send the message. So far so good, now we just have to get our other script to listen. Now that we know our sender script is actually sending out messages, it's time to teach our listener script how to listen. To do that, we'll open up the listener script, just like we did the sender script. We're going to add the title and description to the top of this script, which is something we forgot to do for the sender. We will be using the listen event handler to listen for messages, but we have to tell the script how to listen first. We'll be using the ll_listen function to teach the script what to listen for. Looking up this function on the Second Life wiki pages, see the ll_listen function has 4 parameters. Integer channel, string name, key ID, string message looks intimidating, but we've already gone over all of these, so it shouldn't be too hard for us. We know that a channel is just a number that messages are sent on, like our previous analogy for a radio station broadcasting of a specific frequency. We see the data type is an integer, so we know the channel will be a whole number. Next is the variable name, which is a string data type. If we wanted to listen to only a specific prim, or avatar, we could add that name here. Since we're going to listen to everyone, we'll just use a set of empty double quotes. The ID variable is a key data type. As with the name variable, we could instruct our script to listen to only a specific prim or avatar that has an ID that matches what we put here. Since we'll listen to everyone, we'll add a special constant here that just means everyone. The last parameter message is where we would add text if we were waiting for a specific message to arrive. Since we're going to listen to any message, we'll just use a set of empty double quotes. So, not too bad, is it? Just a bit more to get through. We'll add the ll_listen function call in the state entry event handler so that as soon as the script is ready, the listener will start right away. The ll_listen function returns, or gives back to us an integer value. This integer, commonly referred to as a handle, is just a number used internally. Because having a script listening uses up resources in the region you're in, it's good practice to tell the script when we don't need to listen anymore so those resources can be used elsewhere. It's like turning off the lights in your home when you don't need them. You don't strictly have to, but if you don't, somebody's going to pay for it somewhere. Stick with me, we're almost there. First, we need to create a global integer variable for the value that the ll_listen function passes back to us. We use a global variable because we have to remember what that value is, in a different function. We add the variable name and the assignment operator before the ll_listen function call. Remember, the assignment operator assigns the value on the right of it to the variable on the left. If we were to save our script now and send a message, the script would hear it, but we wouldn't know that. We haven't added any code to indicate to us that a message was received. The listen event is where we'll receive all messages, so let's make it simple, and add an say function call inside the listen event. Now, if we save our script and touch the sender, we should see some message from the listener. Let's try it. There we go. The sender said, "Testing," and the listener repeated our message. It works. Our sender sends, our listener listens, and tells us what the sender sent. What more could you ask for? Oh wait, a friend of mine just showed up. Let me say hi to him. Well, that didn't go quite the way we expected it to, did it? So what's wrong? If we look at our sender script, I think we can find the error. Yup, just as I thought. Our say call inside the send message function is using channel 0, the public channel. So anything the sender says is public to everyone. Not a way to be a good neighbor. We can change the channel we're broadcasting our messages on, but we don't know for sure if we'll always use the same one or not. We'll add an integer variable and call it channel. We'll assign a value to it that we can easily change in the future if we need to. We never want to go digging through who knows how many lines of code to change a simple value. Especially if that value is used in multiple places. We'll add the variable, but this time we're going to add it in the constants area and we're going to make it all uppercase. Here is an important distinction between the constants that Linden Labs has and the constants we make. Our scripting language doesn't support user-defined constants. It only supports variables. So, by convention, if we add a variable in all uppercase, we're indicating that we're treating that value as a constant and we will never assign another value to it. It's an agreement, that's all. If someone breaks it, all bets are off on if things keep working. So, we'll give our pseudo-constant a value, other than 0, the public channel. Recall, we can use any whole number from about 5 billion. So let's use something we hope nobody else is using. How about minus 256,985? It's as good a number as any. So, let's update the code. We added the new value, now we have to tell our say function to use the new channel. We just replaced the channel 0 in say with the new channel constant. Now if we ever want to change the channel we're broadcasting on, we can change it in one place and that change will be reflected everywhere the variable channel is used. Save our script, but it won't work quite yet. We told this script to broadcast on a new channel, but we haven't told the listener to listen on the new channel. We can just copy the whole variable declaration for channel, from here, and paste it into our listener script. We've established that we can communicate between objects, and we can do it on a channel that others can't hear us. Now, let's make it a bit more interesting. Really, being told what we've already said is, well, redundant. So let's make our listener do something a bit more involved. We'll teach the listener to change color, depending on what the sender says. We've opened up the script for the listener so we can edit the script. We'll replace the say function with a bit of program logic. Thinking about it, there will be two conditions that we might encounter. The sender sends us a message we understand. Or they send us a message we don't understand. So, we'll have to add code for both possibilities. The first thing we need is a variable to hold some color information. Because this variable is inside another function, it's called a local variable, as opposed to the global ones we've used up until now. A local variable is only seen by other code inside the same code group it was declared in. It's referred to as a variable scope. We will add a variable, and call it color, but what data type is it? Color values in Second Life are made up of 3 floating point numbers, each indicating how much red, green and blue make up that color. A vector data type is made up of 3 floating point values, so it seems like a vector would be a good choice for us. We'll add the variable declaration in the listen event handler, because we know that's where messages will be received. Since we won't be using the say function, we can remove that line. When initializing vectors, we need those open and close brackets. It's just something the script requires. Inside the brackets, we have 3 floating point numbers. Each of those numbers has a valid range of 0 to 1. This 1.0, 1.0, 1.0 is the code for the color white. We're going to teach our script to listen for and respond to 3 different messages. Those messages will be red, green, and blue. When the script hears one of those messages, we want to turn the whole cube that color. We use a conditional statement to check for one of those messages. Here, if the message is equal to red, the script will execute the code inside the curly braces. We know a single equal sign is an assignment operator. The double equal sign is how we test for equality between 2 things. When you see equal equal, just think, is equal to. So in this case we read this line as if message is equal to the text, red, execute the code inside the curly braces. That code just updates our color variable by assigning a new value to it. We can add additional conditional statements, called if statements, to check for the messages green and blue also. If we hear either of those 2, we'll update the color variable to the specified color value. Note that messages are case sensitive. This means that a lowercase red isn't the same as an uppercase red. If they don't match exactly, the condition won't be satisfied and the statements in the curly braces won't be executed. So now the variable color will have some known value in it. If we received a message that we understand, that color value will be red, green, or blue. If we didn't understand the message, the color value won't have been changed and will still hold the value for the color white. This is why we initialized the color variable in the declaration. So how do we actually change the color of the cube? If we look up on the Second Life wiki, we see that the function setColor will change the color on one or more sides of a cube. The function takes 2 arguments. The first one is a vector data type that holds the color. The second argument tells the function what side to apply the color to. We're going to use the Linden Labs constant all sides. So there, we added the function call to set the color. Now we just have to save our script. Now that we have saved our script without errors, we can touch our sender cube to test our changes. Well, it kind of worked. The cube did change color, but it changed it to white. White was the color we chose to use if the script didn't understand the message. We'll look at the sender script and see what it's sending as a message. Here's the problem down on line 44. We're still sending our original testing message. No wonder the listener doesn't understand us. We'll change the string constant testing to red. Save our script and touch the cube. There. Our listener turned red for us. Love it when a plan comes together. Now we can try using green and blue also. But I'll do those changes in the default script window, just because it's a tiny change. So our script works. I hope your script is working for you also. If not, take the time to go back and see where your errors are. Once they're fixed and running right, there is an immense amount of satisfaction that comes from even the simplest of scripts. Now we know it works when the 2 cubes are side by side. Let's move our listener way back and test again. There is no amount of testing scripts that goes to waste. That didn't go so well. Once our listener is too far away, it quits working. Going back to our sender script, we see on line 44 again that we're using say to send the command. The say function has a maximum distance of about 20 meters. So, the script is working, the listener just can't hear it. We could change the function from say to shout. Shout has a maximum distance of about 100 meters. That would work, but we can do better. The region say command looks a lot like our say. It takes the same 2 parameters and it has the added benefit of being heard from anywhere in the current region. We can change our script easily to update the function call. Now, save, click, test. There we go. Back to a working state. We can be confident now that no matter where our listener is in our region, it will hear and execute our commands for us. There's more we can do, just to tidy things up a bit. We'll go back to our listener script. All we're going to do is take the code we added to the listen event, and move it to a new function we'll create. Let's call the new function something descriptive. Maybe set cube color. We create the function by entering its name. No spaces allowed. Open and close brackets, and a set of curly braces. This is one time we don't need the semicolon. All rules have exceptions. We will add a string variable parameter and call it color. Just so we don't have to change much. Now, we copy the code from the listen event to our new function. Oops, I made an error adding the parameter variable. I should have called it message, not color, as we will be passing in the text from the message in the listen event. All fixed now. One last thing we have to do is call our new function. Now, save, click, test. That last little bit was just to tidy up the code. The listen event is for listening, not for changing color, so we create a simple function whose only job is to change color. That way, once we start getting more and more code added, we're not running into a lot of script lines that are unconnected. It's just easier in the long run. I do hope you now have a better understanding of how objects communicate with each other, as well as the confidence to go and try some more examples on your own. Maybe get the cube to change to different colors, or maybe have the cube move to different positions. Once you have the basic communication strategy built in, what you tell the listener to do, and what it will execute for you is wide open to your imagination. Change color, change position, spin it, change its shape. Anything you can do to a cube in Second Life, you can now do just by sending it a command. One other thing to note, you can add your sender cube as a HUD, that way, you always have it with you. Thanks for watching. Any questions or comments can be left below. Come see me in World if you like. Bye for now.